introduce Runjiu, who is a fifth-year PhD student from the economics department here at UC Berkeley. She specializes in causal inference, and her research focuses on labor economics, development economics, and the economics of education, including gender inequality, school choice, and labor market discrimination. So please join me in welcoming Runjiu to our seminar today.
Hi everybody, today I'm presenting my project, Education Subpurposes and Missing Women. This is kind of like a middle stage project. I'm using kind of tools and techniques from the economics to speak to a demography question. I would assume that all the audience sitting here today know way more about the demography context than I do. So any questions, any input, feedback will be super welcome. I'm also happy to take any clarification question in the middle of the presentation. So a little bit motivation about the missing woman problem. Here, missing woman does not refer to like women being kidnapped or killed. There's a huge deficit of women relative to men in substantial part of Asia due to strong subpurposes. It could happen at the prenatal stage due to sex-selective abortion, or at the afterbirth stage due to unequal healthcare. So it is estimated that more than 100 million women are missing. And the missing woman phenomenon, to emphasize the importance of this question, brings problem to low and middle income countries beyond ethical and moral concerns. It affects the marriage market, future fertility rate, and overall economic growth. Despite the importance of this problem, there's limited empirical evidence of what mechanism is driving this missing woman problem and what policy or things that we could do to help alleviate this problem. So two research questions I would like to address in this project. Research question number one, what is driving the missing woman problem? In the previous literature, there's like two main strain of factors. The first one is the pure economic factor. If you imagine a very poor family in developing countries that suffer from like getting enough food for the child, then you wouldn't imagine that they prefer getting sons relative to daughters because they want sons to be more productive on a farm to support the whole family. And the second one is the cultural factors. There is deep route of some purpose, belief and cultural norms of some purposes that could date back to 100 years ago. And parents, without any economic factors, could believe that sons are just superior to daughters, and that's why they want sons relative to daughters. So research question number two, whether education could solve the missing woman problem. That's kind of the solution I want to bring today. In theory, one hand, education may decrease gender bias and change the desired gender ratio. So this paper by Nina Lee, published on Journal of Development Economics recently, using DHS data across more than 50 developing countries, show that there's a negative relationship between mother's education and the desired son. On the other hand, education is negatively correlated with fertility. This is pretty much an established fact. So if you consider a fixed level of gender preferences, then the demand for sex selection technologies is much higher for educated families. Like imagine if I'm well educated and only have one child, and I do have some level of some purposes, I better make sure that this only kid of mine is a son rather than a daughter. A little bit cross-sectional evidence in Asia. So in the graph, I have the relationship of education and sex ratio, plotting for 3 countries, China, India, and Indonesia. For some countries, I have mother and father level, but for India, unfortunately, due to the data reason, I only have mother. So I think a couple of like very interesting findings here. The first is like the relationship between education and sex ratio are kind of different for these 3 countries. For China, it's like an inverted U shape. The sex ratio is really high. Oh, here, I should define the sex ratio here. The sex ratio is the number of males relative to females. So if it's, for example, the level of about 1.2 in China, that means there's access 20% of males relative to females. So there's an inverted U shape in China, and the education gradient for India is pretty flat, which means everybody, no matter the level of education, seem to have similar level of some preferences, or at least sex ratio when they realize their fertility outcome. For Indonesia, there's a negative education gradient, which means when people get better educated, we do observe that the sex ratio decreased from a level of 1.10 to a level that is close to 1.07. A little bit background knowledge about sex ratio. So the natural sex ratio is believed to not be 101 due to some health disease kind of reason. I'm not going to elaborate here, but it's normally believed that the natural sex ratio is somewhere between 1.03 to 1.05. So at least you see there must be something happen in both three countries in Asia. Like none of these countries are close to the natural sex ratio that people normally believe.
Is this more or less right now, or what time period is this? Right?
Oh, so the data here we use is the recent wave of the census. So in India, that's the 2009 census. In Indonesia, that's the 2010 census. And for the China, that's the 2000 census. Any questions so far?
How would that look like if you only looked at the population under 5%?
Under 5,
Or just younger rather than the entire population?
sorry, you mean the child under 5?
Right, because this is the overall population.
Yes, no, sorry,
Okay.
so that's the overall population and count the sex ratio among their kids. So all the survived children, the sex ratio among all the survived children. The sex ratio among all the born children. And the figure for the survived children is similar to this one. So like hopefully they answer your question. I think your question is about the whether it's prenatal or postnatal. I think it's postnatal pose a relatively small role in all these three countries. It's more about prenatal stage. A preview of the results in case I don't get to the very end of the presentation. So here I'm using an education expansion policy in Indonesia as a shock to education as a policy shock to education to identify the causal effect of education on sex ratio. The data I'm using here is the 10% sample of Indonesia 2010 census. So the baseline finding is that there's statistically insignificant relationship between education and sex ratio in Indonesia. However, I like to argue that there's huge heterogeneity between ethnic groups. Using the ethnographic atlas data, I can merge that data with the Indonesia census based on the ethnic group. Here I use inheritance law as a proxy of the traditional cultural norm of some preferences. For the group that only acknowledge sons as their legal inheritors, we see the baseline gender ratio is 1.13. And the effect of the education program on the fertility outcome is it helped decrease the gender ratio by 0.02 and increase the probability of having girls by 10 percentage points. For the group that traditional belief to be clear, or say according to the traditional culture norm, clear of this son preferences problem, the group not only acknowledge sons as their legal inheritors, but also believe daughters are entitled to family wealth. So at the baseline, it has a gender ratio of 1.07, at least much closer to the natural rate. And also, I don't see any significant effect of the education program on their fertility outcomes. Another add-on is I find no significant difference between rural and urban areas. So combining these two stories together, the conclusion is it's cultural effects that dominate the missing woman problem, not the wealth versus the pure economic factors. Also, education policy is effective to help alleviate the missing woman problem in traditionally some preferred ethnic groups. This is the summary statistics of missing woman problem in Indonesia. So the total level is 1.08. For those who are more familiar with the Indonesia context, according to previous literature, people tend to believe that Indonesia is a okay country in terms of the missing woman problem. I think your intuition is generally correct. The sex ratio for Indonesia at the mean level is 1.08, at least much better compared to the India 1.13 and the China 1.2. However, there's great heterogeneity across ethnic groups and religion. So based on the inheritance law implied by the ethnic group, the inheritance by son group has significantly higher sex ratio. And the religion as well, like we see that the Hindu group has a sex ratio of 0.1.2, which is very close to the crazy China level. However, like if we break down the sex ratio by urban, rural area, and also per parents in employment sector, we see very small difference between the urban rural areas and the employment sector. So indicating that at the baseline, the culture factors is really important for us to study the missing woman problem. The identification strategy I'm using here is the infant school construction program. It is a massive school construction program that built more than 60K schools between 1974 and 1980. So each district has on average 2 schools being built per 1,000 school-age child. So the regression I'm running here is Y variable, which I will talk about later. So the main outcome variable is the sex ratio, but I will show a series of alternative measures of the missing woman problem and some purposes. In the independent variables, I have this intensity times treatment variable being the main variable I'm interested in, and also this beta is also the main coefficient I want to see. This T variable takes 1 if the child aged 2 to 6 in 1974, and 0 if age 12 to 24 in 1974. So basically, the control group is the children that is too old to benefit from the program, and the treated group is the children that is young enough to benefit from this school construction program. And this intensity variable measures the number of school built per 1,000 school-age children, which means I'm not only, so in this identification, I'm not only comparing across district, but also across cohorts. I'm comparing children that is born in the district that get more schools with children that is born in district with less schools, and also children being young enough to benefit from the program compared to the children who are too old when they were born so that they cannot benefit from the program. There's a series of control variables, including the number of children in the district, enrollment rate, and other inference program, including like water and sanitation program that get launched like at a similar time window with this school construction program. Any questions about the slides? Okay. So the first slide, the regression table I'd like to show here is the fact of this infant school construction program on education. So since this program builds primary schools, we do see that it successfully increased the primary enrolled rate and the primary complete rate for individuals. And on average, that increase, I would say 0.25 years of education. We time the coefficient by 2 because on average, each district had 2 schools being built per 1,000 school-age children. So this graph is for males education. Unfortunately, the hyperlink here today is not going to work. So I'm going to briefly talk about what happens to women. So basically, we see nothing happen to women, like all the coefficients are statistically insignificant. So today, I'm going to only focus on the effect of fathers' education on sex ratio on their children, simply because this school education program, the school expansion program don't have any bite on females' education. The program effect on children's gender composition. So if you focus on this reduced form at the column number 2, we see that it's first of all statistically insignificant, or say marginally statistically insignificant. And to interpret the coefficient, if you take the number seriously, I would like to say if you probably want to time that coefficient by -4 to interpret the effect of the education program on sex ratio. Why? First of all, the outcome variable is number of girls over number of child. I have to do this because that only this outcome variable can make the regression valid and make sense. So to convert the number of girls to child to number of boys to girls, you should roughly time that by -2. That's one. And also again, this treatment intensity only measures 1 schools being built per 1,000 kids, and the program on average built 2 more schools per 1,000 kids. To interpret the coefficient correctly, to convert that to the magnitude, you should probably time that by -4, which means the school construction program on average built 2 schools per 1,000 school-age children, can decrease the sex ratio by 0.004. I would say, to me, that's definitely not a small effect. It's probably, like, I mean, like, I'm probably not able to rule out any large, I'm not able to rule out any, significant effect going there. So there are, according to the link, other identification strategy that could make this coefficient statistically significant, but you don't want to like sell that identification too hard because here this regression table are inherited from the Duflo 2001 paper. I do want to like kind of respect more on the literature and make this the main regression outcome. So the key takeaway from this graph, from this table is that I think it's statistically marginally insignificant. And also the magnitude, if we take the number seriously, is definitely not small. So this is, I would say, the main figure of this main table of this project. I think the previous statistically insignificance masks the great heterogeneity between the ethnic groups. So for these two role of the table, I think we should interpret that as separate coefficients for the group that inheritance by son and for the group of equal inheritance. So the first column shows the program has similar effect on increasing the years of education for these two ethnic groups. And from column number 2 to column number 4, we gradually added some fixed effect. So column number 4 is the preferred identification. If we interpret the coefficient seriously, that means for equal inheritance group, there's negligible effect of education program on sex ratio. And for the son inheritance group, the effect of the education program is successfully at decreasing the sex ratio by approximately 0.01, I guess, like negative, again, time that coefficient by -4. So column number 5 and 6 are adding in fixed effect of urban and industry, and also religion here. So here I'm trying to rule out other stories. Although it's statistically insignificant, but we do see that the coefficients of column number 5 and number 6 is similar to column number 4. So that is saying that adding in control variables, including parents' urban rural status, employment sector, and parents' religious belief does not change the effect or say the significance of the ethnic traditional cultural norms at ethnic groups on sex ratio outcomes. Column number, sorry, Dennis, do you have a question?
Well, I was going to ask a bigger picture question, which is I wonder if you could, so this is an IB strategy. Could you help us understand the exclusion restriction here? So I'm just trying to think this through myself. I thought maybe easier to just ask you. So the idea is, yeah.
Yeah, so I'll quickly introduce column number 7.
Okay,
that is
sorry.
using the instrumental variable approach. So instrumental variable approach, for those who are not very familiar with this, is kind of, so we have 2 outcomes from education expansion program to education, and also education expansion program to sex ratio. So instrumental variable approach is like combining these 2 regressions and get the relationship between education and sex ratio. So this column number 7, so we do see that the coefficient of education sex ratio is for the son inheritance group is large and economically large and significant, however statistically insignificant. And for the equal inheritance group, I would say like both statistically insignificant and economically insignificant. So I would say the problem that these 2 coefficients are not significant is partially due to the unsignificant first stage. So simply because the first stage is not strong enough, that kind of prevent the IB approach to make sense. So to answer Danny's question, I think you have a very good intuition. The IB approach kind of is not really working here because the program do not have a strong effect on years of education statistically. So I would say to the reduced form in this project right now is definitely making sense, but I think the IB approach, you shouldn't take it too seriously. This is just kind of an advising number and figure. If you're really interested in the relationship between education and sex ratio, like if you're answering a policy question, so that is the most important one, but I won't try to make it too seriously. Any further questions? Is that sound of a question or raising hand?
No, it's a camera that keeps going on and off.
Um, so to give you a like more direct idea of what's happening here, I'm listing the major 15 ethnic groups in Indonesia. So I think the first like bold picture of what we're looking at here is first of all, Indonesia is a okay question. Sorry, in general, it's like an okay country on this missing woman because the first ethnic group Hawa takes or the sorry the figures the numbers a little bit off here. So the first ethnic groups takes close to 50% of the population, and the top ethnic groups has the majority of like equal inheritance law and a okay sex ratio to study. But however, like we do see some ethnic groups, for example, Bali Hindu has a very high sex ratio, close to 1.2, the crazy China level. And also another takeaway is that there's a strong relationship between traditional culture norms, inheritance law, and current day sex ratio.
Can you repeat or just tell us again what the inheritance law is?
Okay, sure. So I'm merging the ethnographic ALICE data with the 2010 census. And for every single ethnic groups, I will be able to identify the traditional norms of the inheritance law. So the data of ethnographic ALICE is collected majorly like post pre-World War II. So I measure that as a traditional norm belonging to that ethnic groups. So the takeaway of this figure is there's a strong relationship between traditional cultural norms and current day sex ratio. And what about that interacted with the education policy? So now I'm reordering the ethnic groups just to get the graph prettier. So from the by the baseline level of the sex ratio, going from the highest to the lowest. And the red dot here plot the treatment effect for every single ethnic, estimated on every single ethnic groups. So if the dot is negative, then that means the education expansion program successfully decreased the excess male problem. If it's positive, that means it brings more males relative to females. It's probably a little bit hard to see, like there's a slight increasing trend in the dot. Partially because the baseline sex ratio only has like very slight negative trend. I have this regression plot, but unfortunately I won't be able to show you today. So if we plot the dots separately on sex ratio and treatment effect, there's going to be a very close, very clear relationship, like negative trend. All the like yellow groups are crowded at the upper left corner, which means they baseline have a higher sex ratio and the treatment effect is large and significant. And all the light blue dots are gonna in the bottom right panel, which means baseline they are doing fine, and the education program do not make things very worse.
Do you do the same for your first stage? The reason I'm asking is because it kind of looks like from the table, the first stage is a little bit stronger in the equal inheritance law, traditionally equal inheritance law groups. So I'm just curious, like, would the figure follow these sort of expected patterns if there was a strong first stage of actually expanding education?
Yeah, that's a great question. I should definitely do it for the regression plot. I don't have it today. So from the regression itself, there's no clear difference between the ethnic groups that practice the equal inheritance law and the non-inheritance law.
In terms of the effect of the policy on
Education, yes.
Okay.
So the first stage, yes. I should have a better regression plot to show the trend, but it's definitely not as strong as the sex ratio plot. Yeah, I think probably the expectation would be a relatively equal effect on both groups. So I'm using some alternative measures here as a outcome variable to see exactly what's happening here. Unfortunately, the census don't give us a full fertility history. And also, since these parents are too old, it's also quite invalid to back up the full fertility history just using the family roster. So there's limited outcome variable we could study. Column number 2 and column number 3 both focus on the gender growth ratio, but column number 2 studies the at-birth ratio, and column number 3 studies the survived ratio. I think comparing these two columns, They are normally at the same magnitude, which means the majority of things happen at the prenatal stage rather than the afterbirth stage. And also column number 4 to 7 studies the number of boys, number of girls, the probability of having boy and the probability of having girl. So the only significant bite here is the probability of having girl. The education expansion program successfully increased the probability of having girl by 10 percentage point from the baseline of 80 percentage points, and especially for the son inheritance group, but not for the equal inheritance group. Right, so I think that's exactly what's happening here. They are willing to have daughters rather than only focusing on sons. So this graph presents a lasso kind of specification. So here I'm predicting the growth ratio by lasso approach with a rich set of predictors, including demographics, religion, ethnic, income indicators, and wealth indicators. So column number 1, the coefficients are a little bit hard to interpret, but one thing I want to emphasize is this significant negative coefficient of the interaction between the treatment intensity and the predicted growth ratio. So that negative coefficient tells us that there's a strong negative relationship between the baseline sex ratio and the treatment effect, which means if at the baseline you're doing not good, then the education is helpful. Column number 2 and column number 3 are estimating separate coefficients for two groups of predicted high sex ratio and predicted low sex ratio. So column number 4 here defines high male ratio as the group that predicted to have a higher than natural sex ratio, which is about 0.05. Notice that the number belong to this high sex ratio group is very large, and the number belong to the low sex ratio group is very limited, according to this division. And column number 3 kind of equally split the population into two groups. The high sex ratio group is predicted to have a higher than median, and the low sex ratio group is predicted to have a lower than median sex ratio. So both column 2 and column number 3 are kind of conveying the same idea that the education policy is successfully at increasing the number of girls for the high sex ratio group. And for the low sex ratio group, if anything, it's going to be a negative effect, which means they actually decrease the proportion of girls relative to the whole population. So the last slide I have here is comparing the rural versus urban area. So if the wealth or say pure economic effect story is true, then what we will see is that the education program will have a higher bite in the rural area versus the urban area. So both because they are poor and because they have agricultural land waiting for the sons to work on them. So what we do see is that in terms of years of education, the program successfully increased years of education more in the rural area. However, the sex ratio coefficient is higher in the urban area versus in the rural area. So that actually contradicts to the pure economic effect story. To bring this presentation into a conclusion, this paper revisit the in-print school construction program and find that for the son inherit ethnic group, education is effective in reducing men's gender bias and increase the probability of having daughters. I find no significant effect between the rural and urban area and small difference between the employment sector. Controlling for these factors doesn't change the results on of inheritance law on sex ratio. So the conclusion is traditional inheritance rule from the kinship system is crucial to shape the current day STEM purposes. Thank you very much. That's the end of my presentation.
Thank you very much. Let's open it up to questions. Anybody in the room?
Like 2 slides. I don't know if I misunderstood what you said, but
This one?
yeah, you said that the program would have like increased the sex ratio basically for the low sex ratio.
Yes, that's correct.
Why would that?
That is a great question. So I think so like back to the very beginning of the theory part, it's like when you have more education, there's actually two forces that counter each other. So the first one is presumably you have better, or say more equal gender preferences, which means you think sons and daughters are both good. And on the other hand, if you do have some level of some preferences, then you have both higher demand and more money to pay for a sex selection abortion. So also like in the cross-sectional evidence, we see that like a pretty flat relationship across education level. I don't think it's like these two forces are exactly similar for different level of education. I will more think it's like both two forces increase and that's a counter each other. So I think what's going here is that when you get more educated, you do have more preference for do getting a son, maybe inherit a family wealth. Like if you're too poor, you don't even have anything to give to your children. And also you have more money, you have better access to sex selective abortion.
I had just a question. You mentioned earlier that the school expansion happened along with a lot of other things.
Yes.
And
that's
so I'm just curious as to like where do you fit these other things in the general framing of your results, or like I mean maybe this is another paper, but just like intuitively is a story that it's education along with the other things happening locally.
Yeah, sure. So I really haven't think about that. So the other program is water and sanitation program. What I do in this paper is for every single regression, I control for the intensity of these programs serving the control variables. So all the coefficients presented here are just pure education expansion program for sex ratio. It's definitely going to be another paper if I study the water and sanitation program on sex ratio. But I think the coefficients, like all the coefficients today, are clear of the concern of like what if it's other programs that impacting sex ratio simultaneously.
Go back to the slide, the activities and the red dots that show the effects of.
Red dots?
Yeah.
This one.
Yeah, I'm wondering, is there a difference between like just the overall education, I guess, for each of the ethnicities? Like say for the, what was the highest disparity?
Sorry, you mean the bar?
Yeah,
So it's Valley Hindu group, so they have a baseline very high gender ratio. And the program, like the coefficient is negative, which means you should probably think about this negative. This bar decrease this level of negative. So subtract that will be the new level of sex ratio in the treated group.
yeah. Also, so I guess like most of the ones on the right are pretty positive, so is there a way kind of to relate that to what we were just talking about with the higher educated groups having a less corrective effect from the program?
So it's definitely possible, like if we see a positive program, like I would say the majority of dots are negative, but we do see some positive dots estimated here, which means the estimated result is a positive program effect of like, by positive, I mean there's more males relative to females after the program being treated. Another thing is, you probably noticed that I don't have standard errors here. That's because, for example, for this Bataktoba group, that only takes about 1% of the whole population. So I would say you can definitely trust the coefficient for the Havanese group because it's 50% of the population. But I would say for every single dot, especially when the population is just around 1% or 2% of the population, the estimate is going to be not that precise. So I think the general trend is positive is what I want to show in this slide, and agree with you that some group definitely shows a positive, or say the education expansion program worsen the missing woman problem for them. But for every single dot, probably don't take that too seriously.
Yeah, I've got a quick question. So thanks. This was a really interesting talk. So I was wondering if you could just say a little bit more maybe about kind of the theoretical hypotheses for why we'd expect, higher education to affect sex ratio, and kind of how you're thinking about how your results play with those kind of theoretical expectations.
Yeah, that's a great question. So I think unfortunately, I won't be able to entangle all these mechanisms that going from education to sex ratio. But in theory, I think a lot of things could going on like in the middle way of this education to sex ratio realm. So one thing is, like back to other people's paper and like this Nua and Lee paper, they're saying they found that like if there's a cross-sectional correlation showing that if mother getting more educated, they think they prefer their preferred gender ratio among their kids is much more equal. So they reported more like I want to have one son and one daughter, or say two son, two daughter, relative to I want to have one son, zero daughter, and two son, one daughter. So they're having much more equal gender preferences. And that's using DHS data across 50 countries. I think that's pretty convincing evidence showing that education does change people's belief, not only bringing you more skills, but change your beliefs about things. So the second thing is more about when you get more educated, things happen a lot by like increase your income, increase your wealth, and increase your knowledge about sex selective abortion. Probably you don't even know about it. Probably you don't even know which clinic could help you do it. And a little bit note on Indonesia. So sex selective abortion is actually illegal in Indonesia. So you want to have that knowledge and the money and the access to this technology, especially at the prenatal stage. It's going to be hard to kill your babies when it's born. So especially at the prenatal stage, to get to make sure that the realized fertility rate is close to the desired fertility rate. I think better educated parents have just better ability to make sure that their realized is close to what they desire.
Great, thank you.
So another question about kind of your first stage. So early on, you showed us the graph, or you kind of concluded that there was, I think you couldn't click the button to show us the female regression results, but you kind of told us that you don't detect any.
Let me
any
try.
impact on, this was very early on, sorry.
Yeah, that's the female.
Okay, so the school construction program significantly, substantially increased education, but exclusively for males.
Yes.
Should we interpret that as, or how do you reconcile that with, for example, the first theory we just discussed? And like, just in terms of context, was this kind of a gap between male female education increasing?
Yeah, that's a great question.
Could you repeat the question for the Zoom people?
Oh, yeah, sure. So the question is about, so in this slide, we see that the education expansion program actually didn't increase females' education. So to interpret the results on fathers, does that mean that it means if fathers getting more education means better sex ratio outcome, or say more equal sex ratio outcome? Or it's more about when the gap between father and mother's education increase, you get better sex ratio outcome. So that's the question. I haven't really thought about this. That's actually a great question. So I remember, so Duflo had a follow-up paper at 2002 studying the relationship of both mothers and fathers on second generation. I cannot really recall the results of that paper. I should definitely work on this more. Maybe controlling for mother's education would be a great idea in this idea. I should definitely do it. Yeah, unfortunately, I don't have it today.
I have no idea.
Maria, do it, yeah.
So we have a question from Chad Young at Stanford. Thanks for the presentation. Quick question, considering the possible connection between the number and sex of kids, do we have any idea about the fertility rate in the whole country and within ethnic?
Oh, yeah. I think I do have this in the appendix. Let me quickly check this. So I don't have this for ethnic group today, and simply just look at the overall effect of education expansion program on fertility, like kind of as expected, we see that decrease the number of child in this country. I should definitely have it for every single ethnic group. So that's a great question. I would say like we can actually calculate that by previous graph. If it's here, so the number of boys and number of girls plus together will be the number of child. For the son inheritance group, if anything, that would be an increase. For the equal inheritance group, that's gonna be a decrease, I think. And the decrease, both the increase and the decrease are focusing on the girls. So the equal inheritance group kind of sacrificing their number of girls, and the son inheritance group kind of increase the number of girls. And again, I don't wanna like push that too far because all these coefficients are not statistically significant. Yeah, so I think that's the answer.
I'm just a little, so are you making a causal argument here or is? this-
Yeah, there's a causal argument.
Okay, so the
Yeah.
IV was not significant, so where?
Yeah, but the reduced form is still a causal estimate. That's a kind of a differences strategy by comparing the untreated with the treated.
Okay.
I'm assuming that without the education expansion program, they are going to evolve in a similar trend. So if that assumption is true, that this is a causal argument.
Did you run a linear regression? for this?
Yes, that's a linear regression.
And how that works with an outcome that is only positive? Like it's not defined.
Oh, yeah, that is a great question. I'm running a linear here because, I'm calculating the sex ratio, which, let me quickly recall, and I'm doing a linear. Yes, I think I'm doing a linear here. So the reason is that, actually that's a sex ratio, like instead of a probability of 0-1, whether you have girls or not. For most people, the sex ratio is probably not 0 or 1. It's going to be very close to somewhere like 0.5, 0.66, 0.33. That's the majority of the data points.
But it can be above 1, right?
Yeah, it could be above 1. The problem is that there's very rare data points that is predicted to be above 1 or below 0. So the reason that we want to go from linear to the probit data is that when you get predictions above 1 and below 0, it's going to be unable to interpret. So here, simply because the outcome variable is gender racial, and I also checked that like it's very rare to have a predictions for every single individual to have these outer bound prediction. That's why I'm using linear. And the nice thing about linear is that, so here I'm adding tons of fixed effect. There's like, so with these fixed effect, there's more than 500 independent variables in the regression that greatly increase the standard errors and estimated precision of this regression. So I agree with you, there's kind of a trade-off. I sacrifice the perfect ideal world with everybody inbound regression to trade for a better estimate, more precise estimate. And for probability of having boys and having girls, these are in the program model. Yes. So like for those that is definitely going to be problematic, I have that in the very correct version.
So sorry to harp on this, I'm just interested in the item. So the diff and diff, so you're looking at age, right? So it's basically you're comparing older to younger people.
Yes.
So have you tried some kind of placebo where you?
Yes. Yes. I'm not sure. Yeah, I have it today. Only one
Okay.
graph.
Okay,
So,
you can tell us it.
yeah, there's previous literature kind of showing that these control cohort are a good as compare group for the treated cohort. And also have the placebo here today, and I can actually show
There's not something like these schools were built over time and you can look at when they were, maybe, sorry.
Yeah, like I think it's a valid control group, I would say.
Okay. Any other questions? Okay, great. Well, very stimulating. Thank you so much.
Thank you so much. I appreciate all these questions. I'll definitely improve it.
Thanks so much for having us.